In this video, I am going to solve these three problems taken from the book Principles of Physics, 10th edition. The title of the chapter is Gauss Law. First question. An infinite line of charge produces a field of magnitude 1.7 10 to the power of 4 Newton per Coulomb at a distance 9 meter. So you have the infinite line of charge which will have the magnitude of 1.7 multiplied by 10 to the power 4 at a distance 9 meter. And find the magnitude at the distance 2 meters. So what is given in the first line? You have the infinite line of charge. I'm just taking the positive infinite line of charge. So I'm going to take a positive line of charge which have the field effect of 1.7 multiplied by 10 to the power of 4 Newton per Coulomb at a distance 9 meters. So from the line of charge to a distance, let's we take this is the distance. Okay, so what is the distance? Let's we take the distance is r1. So what is the distance here? The distance they mentioned in the question as 9 meter. In this 9 meter distance from the line of charge, how much field effect you have? E1, which is equal to 1.7 multiplied by 10 to the power of 4 Newton per Coulomb. Clear? Now what you are going to do? You are going to find what should be the field effect at 2 meter. So what we studied in the theory, whenever the distance will be smaller, its the field strength will be stronger. Whenever the distance will be greater, the field strength will be weaker. So here in the first part, your distance mentioned as 9 meter. In this 9 meter, what is your field strength? It's 1.7 multiplied by 10 to the power of 4 Newton per Coulomb. But in the distance of 2 meter, what should be the field effect? So we know the answer. For sure, our answer will be greater than this answer. Am I right? So greater than E1, you will get the value for the distance of 2 meters. That means from the distance of 2 meter, let's we take this is our distance 2 meter. So what is our R2? Our R2 is 2 meter. And what should be your E2? You are going to find this value. So when you work out with this, when you work out with the formula, for sure the answer for E2 should be greater than E1. Why? Because of the distance. So here the distance is 2 meter, the field strength should be stronger. So now we have to use the formula. What is the formula for line of charge? In the theory, we studied the formula for the line of charge is E, that is electrical field strength, which is equal to lambda, which is lambda is nothing but linear charge density. Am I right? So lambda over 2 pi epsilon naught r. So this is the formula. Am I right? Now what I'm going to do? I am going to use this formula for both cases. So we just use this formula for the first case. What is our first case? For E1 and R1, I'm going to use this formula. So first, I'm going to apply this formula for the E1 value and R1 value. So E1, which is equal to lambda over 2 pi epsilon naught R1. Clear? So now what I'm going to do? First of all, I'm going to consider this is our first equation. And I'm going to apply the same rule for the second distance. So therefore, E2, which is equal to lambda over 2 pi epsilon naught multiplied by R2, I'm going to consider this is my second equation. Clear? Now, what is our main aim? We are going to find the value of E2. So for getting the value of E2, I'm going to divide the equation 2 by 1. So I'm going to divide equation 2 by 1. So second equation divide by the first equation. So first of all, I'm going to divide in the left hand side of the both equation, and after that I'm going to divide the right hand side of the both equation. So let's start with the left hand side. So E2 over E1, which is equal to right hand side lambda over 2 pi epsilon naught R2 divided by lambda over 2 pi epsilon naught R1, right? So now I'm going to rearrange this equation. So if you rearrange, what will happen? E2 over E1, which is equal to lambda over 2 pi epsilon naught R2 multiplied by this will go to the numerator, right? So 2 pi epsilon naught r1 over lambda. Now you can cancel the same term. So I can cancel this linear charge density lambda with lambda, and also 2 pi epsilon naught I am going to cancel here. Now what is remaining? In the right hand side we have only R1 and R2. Am I right? In the left hand side E2 and E1. Am I right or not? So but the most important thing, first of all, I'm going to write the equation. Therefore E2 over E1, which is equal to R1 over R2. We are going to find the value of E2. So you have to rearrange this equation again, and after that we are going to substitute the value in these equations. Therefore E2, which is equal to this E1, will come to the right hand side of the numerator. So therefore E1 multiplied by R1 over R2. Now I'm going to substitute the value because we have all the values in the question. So what is the value of E1? The value for the E1 is 1.7 multiplied by 10 to the power of 4. R1 value is 9 meter. R2 value is 2 meter. So I'm going to substitute all these value in this equation. So let's substitute the value here. So if you substitute, what you'll get? The value of E1 is 1.7, I think 1.7 multiply 1.7 multiplied by 10 to the power of 4. 1.7 multiplied by 10 power 4 multiplied by, what is the value of R1? The value for R1 is 9 meter and value of R2 is 2 meter. Now I'm going to find the answer by using my calculator. Let's see what should be the answer. So the value for the E2 is 1.7 10 to the power of 4 multiplied by 9 divided by 2. The answer is 7.76500. What is the value? 76500. What's the unit? Newton per coulomb. So I'm going to make the value in terms of power. So therefore E2 value, which is equal to 7.65 multiplied by 10 to the power of 4 Newton per coulomb. Understand? You can see when the distance reduces, what is our electrical field? Our electrical field would be stronger. So we got 7.65 multiplied by 10 to the power of 4, right? So if you just to see the value for E1. So for the distance of 9 meter, we got 1.7 multiplied by 10 to the power of 4. But for the distance E2, what value we got here? We got the value of 7.65 multiplied by 10 to the power of 4 Newton per coulomb. See the value. It's very big value. Am I right? So that means whenever the distance reduces, the field strength will be greater. So it's exactly proved in this question. Am I right? When we work out with the formula, we exactly prove when the distance is smaller, the field strength will be greater. Clear? So this is the answer for the first question. Understand? Okay. Now we have to go for the second question. Read the questions very carefully. An unknown charge sits on the solid conducting sphere of radius 10 centimeter. So you have a solid conducting sphere. What is the meaning for solid conducting sphere? Whenever the material is conducting, the charges will be sitting in the surface of the sphere. Am I right? So here they mention the sphere is the conducting sphere. So whenever you have the conducting sphere, charge should be sit on the surface. And this sphere has the radius. So better I am going to write something from this diagram. So we have the solid sphere. That means all the charges. We don't know what is the charge exactly sitting on the surface because we are going to find the value of the charge. But what is the radius of the sphere? So for example, if you see this diagram, the radius of the sphere is, what's the value they mentioned in the question? The radius of the sphere is 10 centimeter. 10 centimeter is the radius of the sphere. Okay. If the electrical field 30 centimeter from the center of the sphere has the magnitude of 3 multiplied by 10 to the power of 3 Newton per coulomb. That means from the center of the sphere to a distance of 30 centimeter, how much of field strength you have? You have the value of 3 multiplied by 10 to the power of 3. So let's we take I'm going to use the ruler. From the center to a distance. So we take this is our distance. From the center to the distance of 30 centimeters. So what is the distance here? The distance from here to the center of the sphere, they mention, better I'm going to use the caps or, because we have to differentiate what is the radius, what is the distance. So here the caps or indicates the distance from the center of the sphere to the point. So what's the point they mention? They mention 30 centimeter, right? I think 30 centimeter, right? 30 centimeter. So the caps or values 30 centimeter. In this 30 centimeter, what is your electrical field strength? Your electrical field strength is 3 multiplied by 10 to the power of 3 Newton per Coulomb. So 3 multiplied by 10 to the power of 3 Newton per Coulomb. And it's radially inward direction. What is this radially inward direction? You have to see, brother, you have to read the question very carefully, because this is a solid conducting sphere. All the charges will be sitting on the surface, and we don't know what is the charge, whether it is positive or negative, we don't know. But here in this question, they give a clue. What is the clue they give? All the field lines are radially inward. So for which charge the field lines are radially inward? For the negative charge, it will be radially inward direction. For the positive charge, it's radially outward direction. Am I right? So for example, if you have a positive charge, all the field lines will be outward direction from the center. Am I right? Am I right or not? These things we already studied in the theory. But if you have a negative charge, all the field lines are radially inward direction. So what they given in the question, initially they said they don't know what is the charge, but they said the field strength, the field lines are radially inward. So that means the charge sitting on the sphere is exactly negative charge. Am I right? Am I right or not? The negative charge is sitting on the surface. That's what all the field lines are radially inward direction. Understand? Clear? So that means the answer today we are going to get is a negative value. We have to mention the sign. So how we are just mentioning the sign of the charge? Because in the question they clearly mention it's radially inward direction. So if the field lines are radially inward direction, it says the charges sitting on the surface of the conducting sphere is a negative charge. Understand? Okay. Now what we are going to find? We are going to find two answers for this question. In the first part, we are going to find what should be the net charge. We don't know the charge. We know only the electrical field. Am I right? So by using the electrical field for the point charge, I am going to find the value of the charge. So we already studied the formula. What is the formula for finding the electrical field for the point charge? E, which is equal to K Q over R square. Don't put small r, okay? Because this small r is the radius of the sphere. We are going to find what should be the electrical field, because based on this distance, the charges having the field lines radially inward direction. So I have to use caps R here, and by using this equation, I am going to modify it in terms of charge. That means I'm going to rearrange this equation. Therefore, Q, which is equal to E multiplied by R square over K, where K is the Coulomb constant, which has the value of 8.99 multiplied by 10 to the power of 9, and we have the remaining two values in the question. The value for the R from the center of the sphere to the distance is 30 centimeter, and the Coulomb constant is the constant which will be given, and the electrical field for this 30 centimeters is given as 3 multiplied by 10 to the power of 3. So I'm going to substitute the value. Therefore, Q, which is equal to, our electrical field is 3 multiplied by 10 to the power of 3 multiplied by our caps or value is 30 centimeter. So I'm going to convert that in terms of meter. So how I can consider? So 30 multiplied by 10 to the power of minus 2 the whole square, right? Divided by the Coulomb constant is 8.99 multiplied by 10 to the power of 9. So now I'm going to find the value of the charge. So better we can calculate by using the calculator. So 3 10 to the power of 3 multiplied by 30 10 to the power of minus 2 the whole square divided by 8.99 10 to the power of 9. So what answer we got? 3.00 multiplied by 10 to the power of minus 8. What's the value? 3.00 multiplied by 10 to the power of minus 8. And what's the unit for the charge? The unit for the charge is coulomb. But now we have to mention what should be the value of the charge. As we already discussed, the field lines are radially inward direction. So what charge is exactly sitting on the sphere? The negative charge. So what should be our answer in terms of mentioning the charge? It is a negative charge, that is nothing but Q, which is equal to minus 3.00 multiplied by 10 to the power of minus 8 coulomb. Understand? So this is the answer for the first part. This is the answer for the first part. Clear? Okay, now we have to find the answer for the second part. What is the answer for the second part? What is the charge density? Here they did not mention whether it is a line of charge, or that means the linear charge density or the volume charge density or the area charge density. Am I right? We don't know, but you have to see the diagram. This is a sphere. The charge is sitting on the surface of the sphere. That means this is nothing but the surface charge density. So you have to use the formula for surface charge density. So in theory we studied for the linear charge. What is the formula for linear charge? Linear charge, which is equal to charge over length, surface charge density sigma, which is equal to charge over area, and then the volume charge density rho, which is equal to charge over volume. All these things we studied in the theory, but for this question we have to use this formula. Why? Because here the charge is sitting on the surface of the sphere. That means we have to consider the surface area of the sphere. Am I right? So I'm going to use this formula for the second part. So let's start. So the formula for the second question is the surface charge density. Surface charge density sigma, which is equal to Q over A. What is this A? A is nothing but a surface area of the sphere. Why? Because the charge is sitting only on the surface. Am I right? Therefore, the surface area of the sphere is 4 pi r square. So therefore, sigma, which is equal to Q over, I am going to substitute the formula for the surface area of the sphere. The surface area of the sphere is 4 pi r square. Now, here I have to substitute the value of the charge. So what I'm going to do, I'm going to take the answer of the charge from the first part, and I'm going to substitute here. So in the previous question, in the previous part, we find the answer for the charge. So what's the value of the charge? Minus 3.0 multiplied by 10 to the power of minus 8 divided by 4 multiplied by pi multiplied by, what is our r? Because the charge is sitting on the surface. So what is the distance? Here the distance is nothing but the radius is the distance. Am I right? So I have to use this value of the radius. So in the question they clearly mention the radius of the sphere is 10 centimeter. So where if you just see any direction in the sphere, all the radius are exactly constant. So I have to use r value as 10 centimeter here. Clear? So that means 10 multiplied by 10 to the power of minus 2 the whole square. Understand? Now I'm going to find the answer. So take your calculator. Minus 3 multiplied by 10 to the power of minus 8 divided by 4 multiplied by pi multiplied by 10 to the power of minus 2 the whole square. So I got the answer as minus 2.39 multiplied by 10 to the power of minus 7. What's the unit? Charge over area. The unit for the charge is coulomb and unit for the area is meter square. Am I right? So coulomb per meter square is the unit for surface charge density. Understand? So this is the procedure for getting the answer for the second part. But you should memorize, you should remember the formula for the surface area of the sphere. Clear? The surface area of the sphere is 4 pi r square. It's very, very important. So this formula will not be given. You have to remember this formula. Understand? Okay. Now we have to go to the third question. Read the question. A uniformly charged conducting sphere of rate of 6.6 meter diameter. So you have a conducting sphere again. So this conducting sphere has the diameter. So what is the diameter? For example, if you have the sphere means this is the diameter. Diameter is the line which is passing through the center of the sphere. So what is the diameter of the sphere? So better I will write what is given. So the diameter of the sphere d, which is equal to 0.60 meter. And from this, you can easily find the radius. So now I'm going to find the radius. So the formula for radius R, which is equal to the diameter divided by 2, which is given by 0.60 divided by 2, which gives you the answer of 0.30 meter. Clear? Okay. So you have a conducting sphere and the charges are distributed uniformly, and then the sphere have the diameter of 0.6 meter, and it has the surface charge density value also. So what is that surface charge density? They are mentioning the sigma. Sigma is the surface charge density. What's the value? The value for the surface charge density is 5.7 microcoulomb per meter square. So what is the value of micro? The micro value is 10 to the power of -6. So I have to write 5.7 multiplied by 10 to the power of -6 coulomb per meter square. And again, you have to deal with three questions. In the first part of the question, we are going to find what should be the net charge on the sphere. So that means we have to find the value of the charge. So first of all, we are going to find the value of the charge. And in the second question, so what we are going to do? We are going to find what is the total electric flux leaving the surface. What is the flux? The flux is nothing but phi or phi. Am I right? So phi value we have. And the third part, what we are going to find? We are going to find what should be the net flux through the concentric Gaussian sphere of radius 2 meter. Suppose if the sphere of radius will be 2 meter, what should be the flux? They are asking. So that means we are going to deal with the theoretical part also. So I'm going to answer one by one. So that means the third question also, you are going to deal with the flux. But the condition, the radius should be 2 meter. Clear? Okay, now the radius in the first part, the radius is 0.3 meter. Am I right? So if your radius of the sphere will be 2 meter, what should be the flux? So you have to find. So let's we start with the first part. What is in the first part? We are going to find what should be the value of the charge. So already we studied the formula for the surface charge density. From the surface charge density, we know the formula. It's charge over area. Am I right? Clear? And from this, I'm going to find the charge. So therefore, the charge which is equal to sigma multiplied by area, and here the area is nothing but surface area of the sphere. So the formula for the surface area of the sphere is 4 pi r square. So you have to substitute this formula here. So once you substitute the formula here, you will get the value. You will easily find the value of the charge. Therefore, sigma multiplied by 4 multiplied by pi multiplied by r square. Clear? Now I am going to substitute the value. So what's the value of the sigma? They already gave the question, the value in the question. So it's 5.7 micro. So 5.7 multiplied by 10 to the power of -6 multiplied by 4 pi multiplied by radius of the sphere. What is the radius of the sphere? The radius, because the diameter is given, from the diameter we can easily find the radius. So the radius is 0.30. Am I right? So therefore 0.30 the whole square. So now I'm going to find the value of the charge. So take your calculator. 5.7 10 to the power of -6 multiplied by 4 multiplied by pi multiplied by 0.3 square, right? So the answer I got is 6.45. What's the answer? 6.45 multiplied by 10 to the power of -6, and the unit for the charge is coulomb. So this is the answer for the first part. Understand? Okay. Now we have to deal with the second part of the question. In the second part, we are going to find what should be the electric flux. As we already studied the definition for the electric flux, you have two formulas. Am I right? The flux which is equal to EA. Am I right? And also we studied the flux formula as the charge enclosed in the sphere divided by the permittivity constant. Am I right or not? So I'm going to use the second part because we have two formulas for the flux. So I'm going to deal with the second part. What is the second part? The flux which is equal to the charge enclosed in the Gaussian surface divided by the permittivity constant, because the permittivity constant epsilon naught is given, the value for the epsilon naught is 8.85 multiplied by 10 to the power of -12. So now what I'm going to do, in this place of charge, I'm going to take the answer, I'm going to substitute here. So what you will get? Sigma, which is equal to 6.45 multiplied by 10 to the power of minus 6 divided by, what is the constant value of this epsilon naught? 8.85 multiplied by 10 to the power of minus 12. Now I'm going to find the value of the flux. So what's the value of the flux? The value of the flux is 6.45 10 to the power of minus 6 divided by 8.85 10 to the power of minus 12. So the answer for this flux is 72813.55. So I'm going to write this value of the flux in power 7.29 multiplied by 10 to the power of, what's the value? 1, 2, 3, 4, 5. Am I right? So 10 to the power of 5. What's the unit? The unit for the flux is charge per. You have to use the formula, the value for the flux. So if you use the unit for the permittivity constant, so you will get the final unit as Newton meter square over Coulomb square. Clear? So this is the unit. Am I right? Clear? Okay. Now we have to deal with the third part. What is our third part? We are going to deal with the flux. If the radius is 2 meter, what should be the flux? What we studied in the theory. Because if the radius doesn't matter, am I right? Because the charge enclosed in the sphere is same. Whether the radius will be increased or decreased, that's not a matter. So what charge is exactly inside the sphere? So that means even if the radius is changed, what should be the flux? The flux will be the same value because the charge is enclosed in the sphere has the same flux. Whether the radius change or not, the flux for the third part is exactly the same. So that means 7.29 multiplied by 10 to the power of 5. Clear? Understand? So this will be the answer. This will be the procedure to solve the question. Understand? So how we got the answer for the third part? It's very easy because what they mention, again, please read the question. I will explain one more time. So here, initially the sphere radius is 0.3, but now what they said, if the sphere radius is 2 meter, what should be the flux? The radius doesn't matter here. Okay, even if your radius increase, because the charge sitting inside the sphere will be the same. So based on the charge, the flux will be there. Am I right? So that means if the radius change, it has no issue with the flux. So what answer we got from the second part will be the same answer for the third part also. Clear? Understand? Clear, my dear? So this is the answer for the last question. That's it. Okay. Actually here the unit I think here I mentioned is wrong because the unit for the charge is Coulomb and the unit for the permittivity in free space is Coulomb square over Newton meter square. Am I right? So that means the unit will come like this. Am I right? So this Coulomb get cancelled with this Coulomb. Therefore, Newton meter square over Coulomb is the unit for the flux. But here I mentioned as Coulomb square. Am I right? So please kindly change this. So that means this unit is not for the flux. The unit for the flux is Newton meter square over Coulomb. So here also, what's the unit? Newton meter square over Coulomb. Understand? Clear? So if you don't know the unit for the formula, better apply the unit for each and everything. So here the unit, the formula for the flux is Q over epsilon naught. So the unit for the charge is Coulomb and the unit for the permittivity in free space is Coulomb square over Newton meter square. So by that you can rearrange the unit. Finally, you'll get the unit for the flux. Clear? So that means the answer for the flux, the unit for the flux is Newton meter square over Coulomb. Understand? Yes, thank you.